Okay, all right. Okay, so today it's going to be lab 6, right? But this one we are referring to, I mean, like the document is stating that it's lab 5, which is referring to the previous document used by previous class, right? So, but for us, it's going to be our lab 6 exercise. So, in this exercise, we're going to do work on the finite state machine, which I haven't covered in your lecture yet, but I think it should be okay. I mean, because I'm going to explain a little bit on what is a finite state machine, and then you guys are going to do the activity and then try to understand it by doing it, right? Alright, so we're going to refer to this module. Okay, but before that, I mean, there's another document that I've shared with you guys. So this is the lecture note that I found that explained on the FSM. So basically, in our class, we're going to learn two different finite state machine type, right? So the first one is Moore, Moore, Moore state finite state machine. The second one is Mealy, right? Mealy finite state machine. Okay, here I'm gonna briefly explain to you guys what are the main difference here, right? So as you guys can see, I mean, both state machine right now are doing mean like two state, right? Two state. So they mean like okay. I mean, I'll give you example here, right? When we see, I mean, we can have a lot of states, right? We can have 9 different states. We can have 8 states. It's up to you. But to ease the explanation, so we are doing two state, right? For example, we are talking about light, right? So the light in your room, right? So there are two state of your light, right? So the state 0 means that your light is off. Light is off, right? But for state 1, light is on. Okay, so I mean there are two states here. So state 0 and another one is state 1. Right, so you can move to from state 0 to state 1 and from state 1 to state 0, or you can remain in state 0 or you can remain in state 1, right? Okay, now, okay, going back here. All right, as you guys can see here, so there are two states, but if you see in Moore FSM, right, finite state machine, I mean there are 3 circle here. Okay, why? Okay, because this is the main difference between Moore and Mealy, right? For Moore, before you are going to the other state, so there's a safety precaution here, right? So they double check the condition, and then after they confirm it, then they're gonna go into the other state. Whereas for Mealy, I mean, you can directly jump, right, from state 0 to state 1. All right, so basically that are main difference between Moore and also Mealy. So the usage is gonna be for different usage, right? So might be some application suit more FSM better, but might be some other application suit Mealy FSM better, right? So it's really depend on the application. But the main objective in this lab today, we want to study the difference, right? So the difference between the Mealy and also the Moore. Right, so by doing the lab exercise, you guys are gonna see what's the difference between Mealy. So we're gonna see the difference between Mealy and also Moore FSM. All right, so the code is already here. All right, so the code you can just copy and paste and then try to run it. Okay, but what is the exercise? So the exercise is here. All right, so the exercise is here. So I mean, like you can ignore the bottom part here, right? So what you guys need to focus is here, right? Design a sequence detector that search for a series of binary inputs to satisfy the pattern 1101. All right. So basically, what you guys gonna do, right? So what you guys gonna do is that, okay, let's erase all. Okay, so they're gonna be for your block diagram, right? So your block diagram or your circuit, so they're gonna be 4-bit input, right? So it's gonna be 4-bit input, and then there's gonna be the clock, right? Because FSM, both of the design need to have clock. And then there's output. So what's the output here? I mean, you can check. So the output is Z or Z, right? So the condition of Z, it will become true every time the sequence is found. So what are the sequence that you're looking for? The pattern is 1101. So you are having 4-bit input. So you are looking for pattern. Look for pattern pattern 1101. So of course, I mean, you guys gonna varies the input here, right? So it's depend on you. So you can give variety of input, and of course including 1101 in the pattern. If your system detect there's a 1101, the output Z will become high. So this is your Z. Whenever they detect the pattern 1101, right? So the Z will become high. Right, so this is your pattern here, right? So this is your pattern. So as long as it detects 1101, then Z will become high. Apart from that, Z will become 0, right? So the rest of the input, if it's not 1101, Z will become 0. Okay. Then, of course, they're going to be two conditions, right? So two state. So your two state here, state 0, and state 1 will represent Z value, right? So this is your Z value. So state 0 and state 1. So you have to, based on the code here, right? So you have to design, I mean, put a condition, you have to modify the code a bit, and then put a condition, try to search for input pattern 1101. As long as it detects 1101, it's going to go to another state 1, which is Z is equal to 1, right? So as long as it's not detecting the pattern 1101, it's going to go back and remain at state 0, which is Z is equal to 0. All right, so you guys have to do both, right? Both for Mealy and also Moore, so that we're going to see what are really the main difference in terms of the output waveform, right? For Mealy and also Moore. All right, so I think that's all for the explanation for this today's lab or this week's lab. So if you guys have any question, please ask me now, right? I'm gonna answer it for you guys.